Emma, can you hit the front light for me, please? Awesome. I guess one kind of warm-up review type of thing. Totally my fault. I wrote it wrong on the slides yesterday, and then I started teaching, and then it was up on the slides, and I got nervous, and I didn't correct myself. But eventually, I corrected myself. But I guess the point is, PERT, right? On the slide, it said P equals. Whoops. This is what it said on the slide that PERT was, okay? And even as we were going through it, I was like, this doesn't seem right because we should have something right here. We should have our starting amount. We should have our principal. What PERT actually, and what I should have had, and the slides are updated now, but is A equals PERT. Okay, so make sure that this is what you have in your notes, that our amount equals our principal times e to the RT. That is PERT. And when do we use PERT instead of compound interest? When it's compounded continuously. Yep. So, again, my fault. I went with the slides, got nervous, didn't correct myself, and kind of, I don't know if everyone caught it when I went over that again yesterday. So that is something to fix. Today, we will be able to define and evaluate logarithms. Now, have you guys worked with logs at all?
I don't even know what that is. Only the people that did stuff in the spring.
So, okay, yeah, gotcha. So we're going to learn what a logarithm is then today. We will be able to use inverse properties of logarithms. So we're going to talk a little bit about, well, not a little bit, a decent amount about inverses. And then graphing is something that we're not going to quite get to today, and that will not be on your quiz, but probably when we come back from break on that Monday, we'll do a big review of what we've talked about, and then we will add graphing to that as well. So we're not going to talk about graphing today, but we will get to that eventually in a while. So let's start with some vocab stuff with a logarithm. A logarithm is, well, here's what our basic form of what a logarithm looks like, okay? We would call this log. The b is our base. Log, base, and then whatever y is. So let's say it was something like and then here we had 15. We would say this is log base 9 of 15 is what we would see, or is how we would say this right here. Okay? A logarithm is something like a function in our calculator, kind of like e, but not exactly like e, because e we know is 2.7 and all the rest of it. The logarithm is not a specific, like, one number value. Okay? And you'll see what I mean in a little bit. But we'll be talking about logarithms today. Something important to note, and this is my favorite, one of my favorite things in Algebra 2. And this is completely stolen from Mrs. Stone. So when you see here, you can say this to the this equals that. But an easy way, or another way that we can rewrite logarithms is our base to the x, or whatever we're equal to, equals what is in our logarithm. So this raised to the this equals that. So, for example, if we have log base 9 of 15, we would say that this to the this equals that. That is another way that we can write a logarithm. This to the this equals that. Okay? And we'll get some practice with that right now. Rewrite each equation in exponential form. So we would consider this, I mean, it kind of makes sense, to be exponential form. So if we are rewriting log base 2 of 16 equals 4, we would rewrite it as this to the this equals that. Okay? And we can check it, right? 2 to the 4th does in fact give us 16. So we are on the right track. On the next one, this to the this equals that. Bless you. 4 to the 0 equals that. We're just rewriting our logarithm. This to the this equals that. And last one, this to the this equals that. Now you could see on these, and is that our next example? You could see on these where maybe they would throw, like, let's see, if we had log 4 x to the equals 0, you could see where they would have you solve for x, right? Maybe they would put x down here. I guess I could do about it. So I probably wouldn't put x down there. But you could see where in these questions that they would put an x and we would have to solve for x. Does that make sense?
Yeah.
You tracking with me? So now if we go the other way, rewrite each expression so that it is in logarithmic form. How would we, does anyone have an idea of how we would do that? Yeah, Faith?
So it would be like log, because 5 would be the b,
Okay.
and then 2 would be the x, and then y I think is still
Sorry, I couldn't hear.
I don't know what y would be.
Not sure what it would be. Ryan, help her out.
Wouldn't it be log 5 and then in parentheses be 25 equals 2?
Oh wait, yeah.
Would it have to be
Yeah,
parentheses?
Now, this to this equals that works really well when something is in this form, right? That's easy to think about. But to think of this to the this equals that, like backwards, is pretty difficult, right? And Faith kind of showed that well. She was trying, you could see she was trying to think about it in her head. How would that be in reverse? Here's how we want to think about simplifying something like this, okay? What we're going to see, and as we work with these logarithms more, and as we start to work with inverses, is that the, bless you, everyone's sneezing today, is that the logarithm and an exponent undo each other, okay? And here's what I mean by that. Logarithms have a base, okay? So logarithm, our base 5, if we log both sides, one of our rules of a logarithm, and there wasn't a way for you to know this yet. One of the rules of our logarithm is that log 5 of 5 squared cancels this out. We are left with just 2. Okay? So if we log both sides of this equation that we start out with, then we are able, if we log it with the same base, then we are able just to bring down that exponent. Let me show you another example. So we started out, by trying to work backwards, which you guys did a pretty good job of. But here's how we, here's the more maybe of the math or the steps behind what we're actually doing. If we have 10 to the negative 1 equals 0.1, we want to write this in logarithmic form. We're going to log each side, base 10. Log each side base 10. That brings our, are you good? Is that a sneeze?
No.
No? Okay. I just totally missed something that was right in front of me. No?
No.
Do I need to move on?
No. Yeah.
Oh, okay.
They're distracting us.
Now I just kind of want to know. I got to move to the other side of the room. Now if we log both sides at the same base, then that brings our exponent down. So if we look at letter C, what do we want to log each side by? Log base what?
8.
Okay. we look at number or letter D, what do we want to log each side by the base of what?
6.
Yeah.
Log base 6.
Do we have questions on that? I totally missed something. Worse than the front row today? I don't know about that.
Yeah, we haven't done anything.
That's true. So a couple special. Do you guys need to go take a walk or something? Are you guys gonna be okay? Lauren, you good? All right, sweet. Couple special situations with logarithms. What? I'll show you where the logarithm button is in a second on your calculator if you don't know already.
It's right next to 7.
Dang it, Aiden, you gave it away. That's all right. Log base b, no matter what this is. If there's a 1, log base b of 1 is always 0. Because no matter what that b value is, this to the this equals that, it's always going to equal 1. Right? Anything lifted to the 0 power always gives us 1. So one special situation there. Our second special situation. Log of b times b, log of b, log b, I'm getting my words mixed up. There we go. Log base b of b will always equal 1. That is why, maybe this slide should have went before this one, but that is why we can, like with letter b, we can log base 10, and this would just give us -1, because the log base something of that same thing just cancels out. Just gives us 1. So evaluate the logarithm. Now I'll show you the kind of math way, I guess, that we can evaluate this, and then I'll show you the way that all of you will actually use. Really, this equals x, right? So if we want to do this to the this equals that, we could say 4 to the x equals 64. And we could figure out, we can do a little guess and check to figure out what x would have to equal. The other way you could solve that is by plugging it in your calculator. If you, I'm not sure what it looks like. Okay. If you look at your calculator, you'll see a log button right next to 7, right? Now, when you hit the log button, it doesn't let you choose what your base is going to be, does it? No, so that's a little bit of a problem. So I don't know if on your calculators, there's another. There's a what? Right, and that's what we would put right here. That'd be our 125. But I don't know if these ones gives you a way. There's a long way to do it, but there might not be a shortcut.
If you go to math and then you go down to A,
You scroll all the way
to
down.
A and you plug that, it'll give you the base.
Yeah. Yep. That's the long way to do it.
Oh, it's not that long, though.
Do you want me to go ask Mrs. Stone?
No. Hit math. Oh, that's not as far down as I thought.
It's not bad.
If you just go up,
Or if you go,
It's 3.
yeah,
It is 3.
then you could put the base in. Everyone see that? Math, letter A. And you could go to the next one. Log base 5, 0.5, oh, 0.2. Jeez. We could just plug all of these into our calculator.
Yeah.
Yep. Yeah, go ahead, do it. Practice. Yep.
3.
But you also, if you wanted to challenge yourself, could set it equal to x and do this to the this equals that. And then think about your exponents.
That's too much work.
Oh, okay.
Wait, so -3.
-1.
Which one?
It's B.
Yeah.
C is -3.
Yes. Yep. Has everyone found those buttons on their calculator? How to put their own base in? Good? Vincent? Find it? Good? Good? Andy Klein? Sweet.
Can we listen to Justin Bieber's album?
We're not even close to done yet.
Whoa.
So, that's why I'm sitting down. A common logarithm is a logarithm with base 10. So when you look on your calculator, and if you just hit logarithm right next to 7, that assumes that it's base 10. So anytime that you see something written as just log of whatever, then you assume that it's base 10. We don't write 10 down here, okay? Logarithms are typically base 10. So a common logarithm is a logarithm with base 10. Now here's a new thing for us. Have you guys worked with natural logs?
Yes.
ln?
No. That button's right under it.
Yeah. A natural logarithm is a logarithm with the base e. So again, we don't write this log base e. Instead, we write just ln, which the natural log is nl. Log, I don't know why it's ln. Couldn't tell you. I think it's something with Greek.
So that's natural logarithm.
Yeah, natural logarithm is the ln.
It's all Greek.
Okay?
How would we do it?
So on your calculator, there is an ln button right underneath log. So you could just hit ln. If I said find, wait, I don't want to steal my own thunder. Oh, okay, I won't. Okay. Evaluate log of 8. Now it doesn't tell us the base, so we assume that it is what? 10. So if we just go to our calculator, hit log, we don't even have to go through and find our base. We can just hit log. Log of 8, we should get a nice decimal.
3.
0.903089987. Everyone got that? Just hit log. Good? Aaron, we good? Gabby, got it? Sweet. Now, let's do part B. Right underneath ln of 0.3. What do we get? Good. We good? Logarithms, natural log. Okay? Now this is where things will get a little bit interesting. This is the last thing we've got to look at. Okay? Inverse. By the definition of a logarithm, it follows that the logarithmic function, g of x, is the inverse of the exponential function, f of x. This means that if we, like you can see here, and it's a little tricky to see, this is just the nice textbook version. We'll look at some examples which might be more helpful. So if you're looking at this like what the heck is going on, just wait for the examples. All that they're saying here though is that if we take f of x, put it into g of x, it all simplifies out to x. So they're just showing that these are inverses. All right. In other words, exponential functions and logarithms undo each other. Here's what we mean by that. If we want to simplify 10 to the log of 4, what do we think we would do? Any ideas? Any ideas? Okay, well, that is one option. Plug it in. What does it give you?
4.
4. Here's why. Again, exponents and logarithms undo each other. So this is really log what? Base 10. So since it is log base 10, they undo each other, and we are left with just 4.
Whoa.
I did not get
Do it. Put it in both of you.
Okay?
that.
Logarithms and exponents undo each other. The reason that we are looking at this, if we have a problem where, like, let's say, well, in our compound interest problems, right? There are some times where they would give us something like this. Right? Where they would give us the amount. Sorry, back row. They would give us the amount, and we would need to find t. And what did we do to find t? What did we used to do to find t? Earlier this week. We would either guess and check, or we would put this into our y equals and look at our table and see when our x value was close, or our y value was close to 4,000. Right? 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 Now that we have logarithms, we don't have to plug it in and look at our table anymore. And we'll get to that eventually, but that's why we're looking at this, okay? Because it helps us solve for what is in the exponent. If we look at part B, we have log 5, 25 to the x. Now, what? Someone said something. Now, you think so? Now, log is base 5 right now, but we have 25 in here, so we can't cancel it out. So how could we rewrite 25 so that maybe 25 was a base 5 to the something? Yeah. Now that we have log base 5 of 5, remember those just cancel out and equal, I mean, they don't cancel out, technically they equal 1. But we are left with just what was in our exponent. Pretty sweet, huh? We can now solve stuff that's in the exponents. We couldn't do that yesterday.
You're right. We're learning.
Emma shook her head. She's like, I still can't do this today. What are you talking about? Sorry, I just roasted you. That was mean.
What? It was funny.
Inverse.
Inverse.
Now, we follow the same steps as we used to with our inverses, okay? What is the first thing we do when we get an inverse? First thing, what should we do?
Graph it.
Did you say graph it?
Look.
Yes. Switch our x and our y.
So close to that.
Now, how could we get this y out of the exponent?
Square root.
Anybody? How could we get this y out of the exponent?
I was gonna say square
Right
root
up
too.
under the.
You hit the log button.
The natural.
Foil.
No, that's not right.
The
Log
log
it.
button. I told you.
That's what I was gonna say.
We got to bring it on down now, log both sides, people. That's my second favorite thing in algebra 2. Bring it on down now, log both sides. Hey, if we go log base 6, right? We cancel each other out.
Oh my goodness.
Keelan, even if you're faking it, I appreciate it.
Wait, can you say over time to bring the log down?
We bring it on down now, log both sides. What?
This is the way you say it.
No, that's what we need to do. If we have y in the exponent, the only way we can get y out of the exponent is bring it on down now, log both sides. That's from Mrs. Stone. You can ask her. You can say, Miss Stone, today we learned about this to this equals that, and bring it on down now, log both sides.
I don't. There's like
Can I
three
go tell
words
her?
in
And
there.
she would probably be like chunk and do the X and that's
Let's look at that one more time, because I think that went for 99%.
You're gonna get some recoil.
We are solving for the inverse, okay? instead of, we don't like writing things, when we're doing inverses, we don't like writing things with f of x. So we rewrite it as y equals, same thing, 6 to the x. First thing we do with an inverse, like Ryan said, the old switcheroo.
The log it.
Now, we have a problem because y is right here. So what do we do to get y out of the exponent? Close. Bring it on down now, log both sides. Now, the important thing is, since we are trying to, like, our base here and our exponent is 6, right? So to get that y down, thank you, Ryan. So to get that y down, we need to have a log base 6 on both sides.
If we need to get rid of the y, why do we even have one up there in the first place?
Well, we need to bring the y down.
Bring that down.
Because we're finding,
Why do we just do the y?
because we're finding the inverse, right? We're finding the inverse. So to find the inverse, the first thing we do is the old switcheroo. Now, again, log 6 just equals 1. So we are left with y.
Equals log 6x. And that's 1 point.
Well, no, that's our, like, this is a graph, right? Y to the, or y equals 6 to the x is like an actual graph. Eventually, we'll get to graphing the inverses, but we just wrote the inverse. Pretty cool, huh?
Yeah.
Okay, good. Now, letter B, same idea, except we have an ln. Okay? Now, ln's are a little bit different. Okay? What's the first thing we do if we're finding the inverse?
Switch.
The old switcheroo.
Then you bring them down and.
Whoa, 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 whoa. Cole, you're getting way ahead of yourself.
How come there's more letters than numbers?
Yeah, I don't like that.
Get used to it. That's math for the rest of your career.
I'm done after all
Now,
What's that? What's why?
This is like the last one. No,
What's a real life example that this is?
we'll get to that later.
Aeronautical engineering.
Stay with me. 5 more minutes. Stay with me. Stay with me.
Hey, we're at like.
Oh, I'm like 7 minutes over.
We're on
But we're just talking. Look, we need to get y by itself, right?
Yep.
But the problem is surrounded by ln. So the way that we get rid of that ln around it, no, we can't ln both sides. Remember that letter E?
No.
Well, it turns out that ln and E are inverses also.
Wait, so you can just take it out. You can just put them on both sides, right?
Oh,
So now
what?
LN's gone.
Yo, what?
Yeah, good job, Trey.
Yes.
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 So ln and e are inverse.
Yeah. Wait, this is actually easy then.
So what's the
When we raise ln to the E, we're raising each side. Whatever we do to one side, we have to do to the other, correct? No matter what. When we raise ln to the E, then they cancel each other out. They simplify. It's really nice. We are left with just what is inside of our ln, so y plus 3. Since we rose this side to the E, we had to raise x to the E, and then we just get y all on its own.
wait? So does that mean like ln since e is like the 2 point something?
Yes.
What is ln an actual number too?
Is ln an actual number 2? Well, ln, it depends what. So remember, ln is our log with a base e, okay? So whatever this ends up being, it depends what's on the inside of the parentheses. Like, this is not a number on its own, okay? We need something inside the parentheses there. I know. I just blew all of your minds in the last 29 minutes.
30. There's no way that was 30 minutes.
30 minutes
That's
long.
short. No, it's not.
Tell that to the virtual students watching.
Hey,
But-
virtual students, that's fell short.
But no, are we? Let's see. Do we have? See, that's the graphing part that we're saving for later because I think we're kind of like, yeah, we're maybe a little overkill right now.
Yes.
Hey.
Dang it!
Let's go.